So today we are solving a problem of circular queue using array. So what is circular queue? Circular queue is an advanced version of the normal queue that solves the problem of a wasted space that we have in the queue. So normal queue, once elements are dequeued, the empty spaces cannot be reused. But in circular queue, connects the last position back to the first, forming a circle. So what we are going to use? We're going to use the basic idea of the modulus operator, and in the circular loop, and also we are using a front and rear to move circularly in the loop, and it will help us in the space utilization of the queue problem. What we will do, we will initialize the size of the queue as 5, and then we will initialize the front, rear, and size. Uh, so our front and rear is -1, and our size is n. So right now we can define the size by 5. So what is that? Like to print the full queue, what we will do is rear plus 1 modulus of size equal to front. So if it's full, the queue is full, it will return it will equal to front, that the rear plus 1 modulus of size is equal to front. And if it is empty, then front is equal to -1, then we can say that the queue is empty. So logic of NQ is NQ and DQ is like when we are like we have to first check that if queue is full. If it is full, we will return that the circular queue is already overflowed. And if it is not, we will pass on to next condition, and we will check if empty, then like set front is equal to rear is equal to 0. Then what we will do, we will just uh, in like increment the rear by one position. Rear is equal to rear plus 1 modulus of size, and then insert the element. Similarly, for the dequeue operation, what we will do, we will check the element, and if element is equal to like reset front is equal to rear is equal to -1, we will say that do the dequeue operation. If it is empty, we will just do the check circular queue is underflow, and then it will just print like circular queue is underflow when we check with the is empty function. And then if it is not empty, what we will just check the front is equal to rear, and then make the front rear and -1. And also we will increment the front is by one, like increment the front and modulus of size. So let's also try to dry run the code. It will just the display function will display the queue. So we will first print the 10. So 10, 20, and 30 we will and 40 will enqueue in that. So when we enqueue, our front is 0 and rear is 3, and we have the element like 10, 20, 30, and 40, and we will display that. It will print the same. Let's also dry run and check, right? So here you can see it will print like 10, 20, 30, and 40. When we will dequeue the element, what it will do, it will like front is equal to 1, and it will remove the 10. So it will dequeue 10, and then also like we have to enqueue 50. It will again make the rear is equal to 4 and enqueue 50 in it, and it will print like 20, 30, 40, and 50. And the space and time complexity of this algorithm is, the space time complexity is O of n, and the time complexity of both the operation are O of 1.